Okay, we're going to look at essentials and basic concepts for section 3.1 and 3.4. Most of this is going to be 3.1. So problem one, a ball is thrown upward from the top of the building 96 feet tall with an initial velocity of 80 feet per second. The distance s in feet from the ball to the ground after t seconds is given by s equals 96 plus 80t minus 16t squared. After how many seconds does the ball strike the ground? Okay, it's going to be on the ground when the height is 0. So I would set s equal to 0, and I would solve. Let me get everything onto the left. Add 16t squared, subtract 80t, subtract 96, and then divide by 16. 16 goes into all three of these numbers evenly. So I'm looking at t squared minus 5t minus 6 equals 0. And that should factor nicely for me. T minus 6 times t plus 1 equals 0. Should do it. T equals 6, or t equals negative 1. T is the time that it takes. And so 6 seconds is what we're looking at. Okay, problem 2. A slingshot is used to propel a stone upward so that the height in feet after t seconds is given by h equals 95 plus 88t minus 16t squared. At what time was the stone 175 feet high? Okay, so I'd set the height equal to 175 feet, and I want to find the time at which it was 175 feet in the air. If I subtract 175 from both sides, also let me get all the terms onto the left, then I'm looking at 16t squared minus 88t minus 80 plus 80 equals 0. Okay, so we can make the numbers a bit nicer by dividing by 8 on both sides. 2t squared minus 11t plus 10 equals 0. Okay, t is equal to, and I'm using the quadratic formula here, the opposite of b, which is 11, plus or minus the square root of b squared, negative 11 times negative 11 is 121, minus 4 times a is 2, times c is 10. And so I subtract 80 from 121, I get 41. Square root of 41 doesn't break down nicely for us. 11 plus or minus the square root of 41 all over 4. Okay, there's 2 different times at which the rock is going to be at exactly 175 feet high, is what I'm getting. Approximately 1.15 seconds. The rock is going to continue to go up, reach a peak, and then fall back to Earth. And after 4.35 seconds have gone by, approximately, and that's when the rock is going to be on the way down, then it's going to cross the 175-foot marker again. Okay, so I would keep these 2 times, and both of them would be involved in the answer there. Problem 3, the length of a basketball court is 6 feet less than 2 times the width. If the total area is 47,000 square feet, find the dimensions of the court. Okay, so I drew a basketball court. The length and the width, the area is 4,700 feet. And the length of the court is 6 feet less than 2 times the width. Okay, so 2 times the width, it'd be 2w, minus 6 is 6 feet less than that. And I want to replace 2w minus 6 in for L. The area is 4,700. Okay, so let's see here. We got 2w squared minus 6w minus 4,700. That's all equal to 0. Okay, and I can make the numbers a bit nicer by dividing by 2 on both sides. W squared minus 3w minus 2,350 equals 0. 50 times 47 gives me 2,350. Okay, so that's the numbers that I want to use there. Of course, if I don't see that, then I'm using the quadratic formula. Okay, so how this factors is w minus 50 times w plus 47 equals 0. W equals 50, or w equals negative 47. Negative 47 is not possible for us to have since the width is negative, and the length is 6 feet less than 2 times the width. Okay, so twice the width would be 100. 6 feet less than that would be 94 feet. So 94 feet by 50 feet. The base of a triangle is 5 inches more than the height. If the area of the triangle is 42 square inches, find the base and the height of the triangle. Okay, here's a triangle. You got B is the base, H is the height. The area of any triangle is 1/2 base times height. The area of this triangle is 42 square inches. So that's equal to 1/2 base times height. The base of the triangle is 5 inches more than the height. So H plus 5. Okay, if I multiply by 2, 42 times 2 is 84 equals, and then distribute the H there, H squared plus 5H. Subtract 84 from both sides. H squared plus 5H minus 84 equals 0 means that, okay, I'm using the quadratic formula here. B is, the opposite of B is negative 5, plus or minus square root of B squared minus 4AC all over 2A. B squared is, 5 squared is 25, minus 4 times A is 1, times C is negative 84, over 2A, 2 times 1 is 2. And so we get negative 5 plus or minus the square root of 361 all over 2. Square root of 361 is 19. So negative 5 plus or minus 19 all over 2. Okay, negative 5 plus 19 gives me 14 divided by 2 is 7. And then negative 5 minus 19 divided by 2 is a negative number, negative 12. Of course, the height can be positive. Okay, so positive 7 inches. And then the base is 5 inches more than that. So 12 inches. Problem 5. The length of a rectangular swimming pool is 2 meters more than twice its width. The pool is surrounded by a deck that is 2 meters wide. If the area of the surface of the pool and the deck is 180 square meters, find the dimensions of the pool. Okay, so we got this pool and a deck that's 2 meters wide on throughout. The area equals length times width. Now the width is W. The length is 2W plus 2. 2 meters more than twice the width. 2W plus 2. Okay, so the length is 2W plus 2 plus 2 plus 2, 2W plus 6. And the width is W plus 2 is W plus 4. Okay, 180 square meters is the area of the pool and the deck. Okay, the whole thing. So I'd set that equal to 180 and then solve. 180 equals 2W squared plus 8W plus 6W plus 14W plus 24. Okay, subtract 180 from both sides. 2W squared plus 14W 24 minus 180 is 156. That's all equal to 0. And if we divide by 2 on both sides there, W squared plus 7W minus 78 equals 0. This is going to factor nicely for us as W plus 13 times W minus 6 equals 0. Okay. W is equal to negative 13, or W is equal to 6. Of course, the width can't be negative. That doesn't make any sense. So the width is 6 meters, and the width and the length is 2W plus 2. So 2 times 6 is 12, plus 2 is 14 meters. Okay. A picture frame measures 12 centimeters by 20 centimeters. The frame has a uniform width on all 4 sides. The picture inside the frame has an area of 84 square centimeters. Find the width of the frame. Okay, so I've got a frame that measures 12 centimeters by 20 centimeters. The frame has a uniform width on all 4 sides, which I'm calling X centimeters. The picture inside the frame has an area of 84 square centimeters. Okay, so I've got 84 equals length times width. The length would be 12 minus x minus 2x. And then the width is 20 minus x minus x, 20 minus 2x. Okay, and that'd be the setup equation that I'd want there. 12 times 20 gives me 240. Negative 2x times 12 minus 2x times 20 is negative 64x plus 4x squared. Okay, so if I subtract 84 from both sides, you have 4x squared minus 64x. 240 minus 84 is 156. That's all equal to 0. I can make the numbers nicer than what they are by dividing both sides by 4. Goes into these numbers evenly. So I got x squared minus 16x plus 39 equals 0. This is going to factor nicely for us as x minus 13 times x minus 3. Okay, so x is equal to 13 centimeters, and x is equal to 3 centimeters. Well, it's not possible for x to be 13 centimeters since the width of the frame, or the length of the frame is already 12 centimeters. 3 centimeters there. Okay. Why don't we do one more here? A rectangular piece of metal is 10 inches longer than it is wide. Squares with sides 2 inches long are cut from the 4 corners, and the edges are folded upward to form an open box. If the volume of the box is 832 cubic inches, what were the original dimensions of the piece of metal? Okay, so I've got a piece of metal, and the width is W, the length is L. The the length is 10 inches longer than it is wide. Okay, so where I see the length, I'm going to write W plus 10. Squares with size 2 inches are cut from the 4 corners. Okay, and I fold up the remains to form a box. The V is the volume of the box. Okay, V is equal to capital L times capital W times capital H. Over here I'm using little w. Little w and capital W are different from each other. Little w represents the length and the width of the metal. Capital W represents the width of the box. Okay, so 832 is the volume of the box. The sides are 2 inches long. So it's going to be 2 inches high there. The length of the box is, I got W plus 10 minus 2 minus 2. So that's W plus 6. And then times the width of the box, I got W is the width of the metal, minus 2 minus 2. W minus 4 is the width of the metal. Okay, so 832 is equal to 2W squared plus 4W minus 48. Okay, and if I subtract 832 from both sides, 2W squared plus 4W minus 880 equals 0. I can make the numbers a bit nicer by dividing both sides by 2. W squared plus 2W minus 440 equals 0. So W plus 22 times W minus 20 equals 0. Negative 22 is not possible. The width can't be a negative. So the width is 20 inches. And the length is 10 inches more than that, 30 inches. Okay. Of course, if I'm using the quadratic formula on any of this, that's fine. Okay, that's totally fine. Actually, why don't we go ahead and stop right here, and we'll get back to this later.